really, really, really big idea coming up with this next section. So this is 11.2. This is section 11.2. It's titled Simplifying Radical Expressions. So we were introduced to radical expressions already, but we didn't really dive deep into how to make them nice looking. I told you we're going to learn how to type them into our calculators and get answers out. But sometimes, because mathematicians really, really like to be mean, they like to keep things as exact answers. And we can't do that sometimes when we're typing stuff into a calculator. It approximates things. So we need to learn how to work with these things. There are several properties. This is probably one of the biggest sections in the entirety of Algebra 2 when it comes to like properties and using them later on in other stuff. We'll see them a lot throughout the semester, so we need to make sure we get these down pat. First thing I'm going to go into is specifically the properties that we have for rational powers. We saw what expressions were that had rational powers, but we hadn't necessarily worked with them a lot. So I'm going to enumerate these. I'm actually going to get rid of this. I'm going to need a lot more room than this. I'm going to enumerate these. So we're under properties of rational powers. The first property, I'm going to start it off with an example. When we multiplied polynomials before, I'm just going to do something simple like x times x. I'm going to put a little superscript here for their exponents, right? We know that an implied 1 is a power for a term that does not have an exponent. Okay, so if I take x to the first times x to the first, we all know that that's x squared, right? And I could even go a step further. I'm like, okay, what is x squared times x to the fifth? Well, you would tell me then that that's x to the seventh. And in general, no matter what the base is, this carries over to generalize into this form, which is going to be the first property. If I've got some term to the nth power, n is just a number. A can be a number or it can be a variable. And I've got some other term multiplying into it with another number as its power. It can be the same number, it can be different. I'm going to take those two powers, and we saw this 2, this 5 combined to get 7. We saw the 1 and the 1 combined to get 2. This ends up just generalizing to adding the powers together. So this is our first property that we have. You take two things that have the same base, multiply them together, you're going to take those powers and you're going to add them together. Keep in mind, I only have one A here. There's only one A. You're not going to have two A's on the right side because you're combining them. Okay, that's the first one. Second one, since we did multiplication, you're probably going to assume that the next one's going to be division. So I'm going to start this off with another example. I've got something like x cubed over x to the first. We would say, hey, I know that. That's x squared. I'm going to divide one x out. Okay, this can generalize again. Let's say I go to x to the 16th over x to the 7th. Well, hey, if I'm taking 7 x's out of 16 x's, I'm left with 9 x's. This also generalizes. Let's say I've got a base, that's a, and I'm raising it to some power n, and I'm dividing by something that has the same base and another power. This is the equivalent of, instead of adding them like I did up in the first one, I'm going to take the numerator's power and subtract off the denominator's power from it. Okay, so take the numerator, that's the first number. The denominator is going to be the second number, and I'm going to subtract the two. That is the second property. The third one is going to be used a lot when we're simplifying these later on in the assessment. So I'm going to start it off by something like x cubed to the fourth. Okay. Well, first things first, what I want to do is I'm going to rewrite this one. So I'm going to change this. I'm going to literally write out x to the third 4 times. X to the third, x to the third, x to the third, x to the third. That's the equivalent, right? I'm taking these and I'm doing 4 of them. Okay. Well, I know from property 1, if I've got things that have the same base and I'm multiplying them out, I can just add their exponents, right? So 3 plus 3 plus 3 plus 3, this is going to be the same thing as x to the 12th. What do I notice here? 3 and 4 are related to 12 in a way that you multiply them together to get 12. So the general form for the third property is if I have something raised to a power and I raise that to an additional power, I multiply those two answers. Okay, this is the fourth property. Take an expression that is raised to a power and then raise that additionally to another power, you're going to multiply them. So those are the first three of them. I'm going to clear this off. There are 5 in total for rational powers. The fourth one is sort of a more complicated third one. So let's say I've got this expression x squared times x to the third raised to the second. There's a couple ways that you can do this. So what I'm going to do first is I'm going to kind of start it off the same way that I did number 3. I'm going to take this whole expression and multiply it out twice. So what's that going to get me? I'm going to get x squared times x cubed, and then again. Since multiplication is commutative, we haven't probably used that word in a while, but everything in here is being multiplied. So what I'm going to do is I'm going to take everything that's kind of the same and move it next to each other. So I can rearrange this to make something like x squared times x cubed times x cubed. And when I do that, I'm going to notice a little something. I can combine these two and these two together. X squared times x squared from the first property gives us x to the fourth. Okay, we're adding those together. X to the third times x to the third gives us x to the sixth. I'm adding those together. If I'm multiplying these out, hey, I notice that this is x to the 10th. I'm not focused on this part really as I am what happened here. The reason why I put these pairs together is because this is the same exact thing as me taking this 2 from my original part and distributing that 2 into each power. So that's what the fourth property says. It says if you've got something like 2 things multiplying together inside a parentheses, which in this case was x squared and x cubed, I just do a and b, and you're raising it to something, you can take that exponent and distribute it into the powers. So this is the same thing as a to the m times b to the m. That is the fourth property. Similarly, we move from multiplication to division just like we're going to do here. The last property that we're going to talk about for rational powers deals with division. Okay, I'm going to start it off with an example and work through it. Let's say I have x cubed over x squared raised to the second. You can kind of imply what might happen, but let's just see how it works out first. I'm going to multiply this out twice. X cubed over x squared times itself. That's what squaring does. It's cubed. And I'm going to kind of do a similar thing here, except the cubes are on top and the squares are on bottom, so they're already kind of next to each other. I'm just going to multiply straight across and see what happens. I get x to the sixth because when we multiply 2 of the same bases together, we add the exponents. That's not going to be x to the ninth. X squared plus, or 2 plus 2 would give us x to the fourth on the bottom. And we'll see later on that this, or actually we already know what this was. This is property 2, which says, hey, if I'm dividing something by the same base, I can take the powers and I can subtract them, giving me x squared. But this part isn't really what I care about right now. I'm focused on how we got here. So the property says if I take something and divide it by something else that has the same base and raise it to another power, I can distribute that power into both. We would see that 3 times 2 would give us the 6 that we have here. 2 times 2 would give us the 4 that we have here. So in general, the fifth property says that, hey, if I take something like a over b and I raise it to some power, this is the same thing as taking that power and distributing it in to the top and bottom. So those are all of the 5 properties for working with rational powered expressions.